Hello everyone, welcome to Learn Overflow. In this video, we will discuss about another liquid problem, that is the maximum point you can obtain from card. This is an as usual and medium level problem, so you need to think something out of this questions. Okay, so let's start with this question. But before that, if you haven't subscribed to this channel already, make sure you subscribe to this channel for regular LeetCode videos and programming concepts. Okay, so in this question, we are said like we are given like there are several cards assigned in a row, and each card are associated with a number of points. Okay, so there are cards being given to us, and there are some points associated with each of the cards. It says like the points are given in an integer array that is a card point. Okay, so that's the card point array we are given. Further, it says like in one step you can take one card from the beginning or from the end row. Okay, so the question says that we can either take a card from the beginning or from the end. Okay, so that's how we can go ahead, and we have to take like exactly k cards. So we must need to take like k cards. That's the number of k being given to us. Okay. Now, it further says like the score is the sum of the points of the card. Okay, so like pretty much like we can understand like we have to take k cards out of here and then see what kind of maximum score we can reach. Like we can take either this card or this card, and then we can take into the maximum value over there, and then we can find a solution to this. Okay, so it's like understandable. Like we need to take k cards and what can be the maximum value by either taking a card from the front or from the end. That's what we need to find out. Okay, it's like says that we are given an integer array card points and an integer k. Return the maximum score. Like we need to maximize our. Now look here in the first example. It says 1, 2, 3, 4, 5, 6, and then 1. And if we need to take k equal to 3, so it says like the maximum point is 12. Okay, so in this case, we first encounter that we are given 1 and 1 at the both ends. Then we need to check like whether which one is the bigger out of the both ends, and then we can like choose one from them. Since one is like both are equals, then we like choose for the next one which one is greater we are getting out here. If we go ahead with a concept like if we find out something equal, then we move into the next element post that, and then we select based on that. So this can be a concept that you think in the first instance, but remember this is the medium level concept or like a medium level question. Okay, so whenever there is a medium level question, try to think something out of the box. Okay, now in this question specifically, if you try to go ahead with such kind of concept like whichever is coming as the maximum at the both end and pick one based on that, then you may not end up in an well, like in some kind of corner cases you will be like you will be destroyed in some kind of corner cases. But in this kind of questions, when we are need to do some kind of like at least like I have to take k cards, and we can take either from the both ends, like either from a beginning or from the end. So if we need to do something like that, so there are basically three ways we can do that. More or less, the three ways are same, but just the way more or less we go ahead with the memory management, you can say. So the first approach can be a dynamic programming approach. But let me tell you that if you go ahead with the dynamic programming approach by storing the maximum value you come across, like k elements from this side, k elements from this side, and then you go ahead with something like two from here and one from here, and then one from here, and then two from here. Okay, so if that's kind of dynamic programming approach, you may end up storing that values in a program like in the dynamic array you create out there. Okay, so that can be the first approach. But the problem with this kind of question will be if you go ahead with the dynamic programming approach, it may give you an time not time limit, like it may give you a time limit exception, and as well as it may give you an memory exception all right also. So in that case, it's better to not go with dynamic programming approach. The next one is the same thing. You can have the other way of solving this is like a prefix sum. So whenever you go ahead with the prefix sum, it's also the same concept. You like sum this prefix, and like the left sum will be this, and then you find the right sum will be this, and on each step you do like you first find the left sum, and then on each step you just reduce and reduce a sum value from the element, like first reduce 3, and then in place of 3 add 1 to that, okay, and add that also, like 1 to, not to the left sum, 1 to another variable called the right sum. Okay, so at the end you try to find out which one is maximum, the initial left sum value or like the current left sum plus right sum value. So you go ahead with like remove another element from here, like only one remains in your left sum, then you go ahead with adding this much element like 6 and 1 to a right sum, and then you find left plus right is maximum, or the any other values goes ahead with the maximum, and you end up finding like when you remove one from the element, like left sum, and then add right sum for 5 in the right sum, you will find that it will go ahead with the maximum value. So that's a prefix sum method, and you can understand like we are using two variables continuously, and then in the two variables we are more or less going ahead with like finding the max and going ahead with storing that in our both variables. Okay, but to improve this, like to improve this thing, like in the memory management concept, like you actually got the solution of what I'm trying to say, right? But to improve this, what we can do, we can reduce it to like a single variable. How we can do that? Rather having a left sum or a right sum, keep two pointers, rather pointers in the sense, on like first find the sum of this left hand, like all the k elements from the left, mark a pointer over here, okay, and mark a pointer over here, all right, at the last element and the last element, and then you remove one element from the total sum and then add that element to your total sum. Okay, so without using two variables, you just came down to a single variable. So this is a way that we call a sliding window concept. So the previous one, where we use two different variables for the sum, then you can see as a prefix sum concept. So you just have two prefixes and just keep on adding them. So that can be a way of solving this kind of questions as well. So I hope I can make you understand how you can go ahead with that. So the basic understanding is the, like the step, you need to like find the sum of the left first, and like left k elements first, and then you keep on removing one element from the left, like the rightmost element of the left sum array, like the first k element, and then keep on adding the rightmost element of the whole array. Now let's go ahead and directly write some code and then try to solve, like try to see whether our approach works or how efficiently our approach works exactly. All right, so we can see that our approach actually works for us. So what the approach is exactly, we as said, we went ahead with first taking the total sum for us, okay, just calculate total sum, and then we just have a check that if any ways that our k is equal to our card length, right? So if we look ahead into the constraint, so we can say that k is less than equal to card points dot length. So if k is equal to card points dot length, then there's no point calculating further. So that's the maximum you will end up having anyways. Like look at this example number 3. There are 7 elements, right? 3 and 7. There are like 7 elements in it. So we find the total sum, and you need to take k values from it. So anyways, you go from the forward, you go from the backward, you will end up in like 7, k equals 7. So there's no point checking for like going further. So you just return the total sum, right? Then we go ahead with like taking a max value, and that max value is storing our total sum value, okay, like total sum of the first k element or the leftmost k elements. Okay, now we do what, we start a loop from I equal to k minus 1, from I equal to k minus 1 till 0, including 0. So since we are trying to take including 0, that's why we are going from k minus 1. The is a 0 index array, right? The exact thing we did over here, we started from 0 and went to less than 0. So here we start from k minus 1 and is going to equals to 0. right? So that's the idea being like the reversing the loop we have over here. So, and we are going like I minus minus over here. And also we're taking another variable being card points dot length minus one. And the card points dot length minus one is the array, like is the pointer that is actually pointing to the rightmost element of our whole array. Okay. Exactly the rightmost value we have over here. So that's the initial pointing, and then we are again moving, doing it as j minus minus. That means we are moving it leftwards. Okay, but like till I goes on decrementing, we keep on like incrementing or like decrementing the j from the rightwards value. So that's the idea behind this. Next we simply do like we in the total sum we add our rightmost array, like rightmost value. We add this and we subtract this our ith value, I being pointing at k minus one. So if there is three, so like 0, 1, 2, so I is pointing here. So we did what? We subtracted 3 from our total sum and added 1 to our total sum. So that was what we did, and then we tried to find like if like max is equals like we just find the maximum of the max. Initially we had total sum stored over here, right? So initially we had max over here. So we just said like a max comma total sum, like whichever is the maximum out of the two values we get, and we store that in our variable max. And at the end, whatever be the output, we just return our max, because we know we just found out our max over here. So this one is the more or less the idea behind solving this kind of array. And in a reverse order, like without total sum, you can have a left sum as this, and then you will go ahead with like this over here. You can return the left sum, and then you go ahead with like say the best case, the max you found out is the left sum, and another variable you will initialize as the right sum being the 0. And what you will do, you will like subtract this cards of I from the left sum and add cards of j to our right sum, and in the end we will find the best answer being either the max value is like max, or left sum or plus right sum. So anyways, you are going at the same way. That will be the prefix sum method, and this will be the normal simply what we say sliding window method. Okay, we are using 2 pointers and like 2 pointers ing, and thus we are reducing the total space complexity. Yeah, exactly. So I hope I can make you understand how this question exactly works. And thank you all for watching this video. Make sure you just like the video if you think it is worth it, and also make sure you just subscribe this channel for regular such concepts, regular such LeetCode videos. You can comment down any of the thoughts or anything that you think we can improve over here, or anything you cannot understand out of this question. So you make sure you just comment down your thoughts for that. I will be happy to help you out in the comments as well. Thank you all for watching this video. Hope to see you soon in my next video. Thank you.